Algebra 1 skills number 44. We're going to look at the geometric sequence, specifically the explicit formula here. Okay, so geometric explicit formula looks like this. And let's look at each of these variables. A sub 1 is the first term of the sequence. R is the common ratio. Now, common ratio is what you multiply by over and over. So if it's a geometric sequence, it is built by multiplying over and over. And then n is just a counter. Okay, so let's look at some examples. Find the 12th term or 12th term of the geometric sequence given. All right, so A sub 1 again is your first term, which is 2. R is what you multiply by over and over. Now here it should be pretty obvious. You're multiplying by 4. But if you're not sure, you can always divide the second term by the first term or any term by the previous term. So R is 4 and n is 12. N will always be, if they need it, they're going to tell you what n is. It specifically wants the 12th term. Here's the formula again. I'm simply going to load that formula so you can see the 12th term is in the 2n positions. A sub 1 is 2, that's the first term, and R is 4, that's common ratio. And then you just compute it. Okay, so this is your answer, 8,388,608. With geometric sequences, you often get large numbers pretty quickly because you're multiplying over and over. Notice also this A sub 12, that's just a label meaning the 12th term. Second example, write the first 5 terms if A sub 1 is 5 and R is negative 0.1. Okay, here's what it is. You just take 5 and you keep multiplying by negative 0.1 over and over. So here we'll notice a pattern. If your R is negative, there is a sort of an oscillation between positive and negative here, because positive times negative is negative, then negative times negative is positive again, and so forth. Notice also that when your R is less than 1, the numbers are going down. It's as if you're dividing by 10 here when you multiply by 1/10. Okay, so sometimes the numbers do go down. Third example, write the explicit formula for the given sequence. So here we recognize that A sub 1 is 2. That's simply the first term. R is 1.2. Again, this time it's not obvious, but you take the second term and divide by the first, or you could take the third term and divide by the second if you so chose. Now notice here that n is not an issue, so we're just going to leave it in. Okay, here's your formula, and we're going to load 2 in the A sub 1 position, 1.2 in the R position. And this is your explicit formula. Okay, it's ready for any n requested. If you want to know the 50th term, for example, you put a 50 in that position, and so forth. Geometric sequences, explicit formula.